Very good evening, my dear friends. Today, one of the most important topic regarding of all competitive exams related to our plant sciences, CPGET 2023 and JLDL and other competitive exams. Anomalous secondary growth, one of the most important topic in anatomy. It is varies from normal secondary growth, and also it is very important. Some of the important plants, some of the examples related to which plants are going to takes place, anomalous secondary growth. So the important topic will going to deliver by eminent resource person, Dr. P. Manjula Madam Garu, Assistant Professor, Department of Botany, RBV Women's College, Autonomous, Hyderabad. Madam, please welcome and start your session, madam. Please welcome.
Okay. Thank you, sir. Okay, is it okay, sir?
Yes.
Is it visible screen?
Clearly visible, madam. Please welcome.
Thank you, sir, for giving this opportunity. So today's topic is anomalous secondary growth. So generally, secondary growth means generally the secondary growth, which mainly helps in the increasing the width or girth of the stem in the plant. So generally, it helps in the increase the width or girth of the stem. So it takes place after the primary growth, after completion of the primary growth, here the secondary growth will takes place through this vascular cambium. So during the secondary growth, the vascular cambium, which is present between the xylem and phloem, it is called as the fascicular or vascular cambium. So the cambium, which is present between the xylem and phloem, it is called as intravascular cambium, and between so during the secondary growth, the parenchyma cells which are present in between these vascular bundles also meristematic and forms the intervascular cambium. So this inter and intravascular cambium which forms a ring-like structure, and it produces secondary xylem towards inside and secondary phloem towards outside. So due to which here the girth or width of the stem will increases. So this is the normal secondary growth. But in some species, anomalous secondary growth will occur. So anomalous secondary growth means that is abnormal activity. So anomalous secondary growth, it is a result of due to deviation of the cambium from its normal function, and due to increase in, so it is the abnormal activity of this cambium. So here anomalous secondary growth is in the result of deviation in the cambial activity from the normal type found in the most of the dicots. That is, normal type is production of secondary xylem towards inside and secondary phloem towards outside. So this is a normal type. But here production of parenchyma cells or conjunctive tissue like that. So anomalous, abnormal activity will take place in this anomalous secondary growth. So again here, Haberland, he classified anomalous secondary growth into two types, that is adaptive and non-adaptive anomalous secondary growth. So adaptive anomalous secondary growth means, so it is generally this adaptive anomaly which is useful to the plant, it is called as the adaptive. So generally it gives some physiological needs, that is to balance. For example, it is seen in the lions, that is woody climbers. So in woody climbers, so due to this abnormal activity, so which will protect the stem. Okay, so non-adaptive anomaly includes anomaly of, so generally it is not useful to the plant. So here anomalous secondary growth, if it is useful to the plant, it is called as the adaptive anomaly. Non-adaptive means it is not useful to the plant. So non-adaptive anomaly, which includes anomaly of Rumex, Behaviour, Bignonia, Bougainvillea, so Mirabilis, Chenopodium. So in this non-adaptive anomaly will occur. So adaptive, which is seen in general in Bignonia. So it is a adaptive anomaly. So here again types of abnormal. So here due to and for this anomalous secondary growth, here this abnormal activity will occur due to the different reasons. So first one is the abnormal behavior of the normal cambium. So here the normal cambium is present, but it shows abnormal activity. That is, so the cambium which forms vascular tissues only in the region of vascular bundles. So the cambium which forms usually large proportion of vascular tissues only in the region of vascular bundles only. So that is, so during the secondary growth, so here it forms a cambial ring and produces only not only in the vascular bundle. So normally throughout this ring it produces the secondary tissue, but here only at the region of vascular bundles only it producing the secondary tissue. So second one is the abnormal behavior of abnormal cambium. So here the cambium is abnormal. That is, it is not present in the common place. That is generally cambium which is present in the vascular bundles region. But here it is present outer to the vascular bundles, extrastellar cambium. So formation of rings of vascular bundles which are embedded in the parenchymatous tissue, or formation of rings of vascular bundles which are embedded in the conjunctive tissue. So due to which, so first reason is due to the abnormal behavior of the normal cambium. Second one is abnormal behavior of abnormal cambium. So first one here. So abnormal behavior of normal cambium. So another first one is abnormal behavior of normal cambium. So in many woody climbers or lions, the cambium is normal in position, but its activity is abnormal, and with the result anomalous structures are formed. Example is cucurbita stem. So here the stem of cucurbita, 10 vascular bundles are arranged. So here in cucurbita stem, so 10 vascular bundles are present, and they are present in 2 rings. That is, in each ring 5 vascular bundles are present. So each vascular bundle is conjoined, open and bicollateral, because in cucurbita it is in cucurbitaceae family bicollateral vascular bundles are present. So this is a special character which is seen in cucurbita. So bicollateral, having an outer and inner cambium. So the outer cambium of both inner and outer bundles becomes active along with the parenchymatous cells of the ground tissue and combine to form the more or less wavy ring of cambium. So that is the outer cambium. They form the ring-like structure. The parenchyma cells which are present between these vascular bundles become meristematic, and they also helps in the formation of cambial ring. So in this normal cambium, which behaves abnormally, as it cuts off secondary xylem and phloem in vascular bundle region only, resulting in the increased size of the bundle. So here it producing the secondary xylem and secondary phloem only in the that is only in the vascular bundles region only, between the parenchymatous region. So it will not producing, only at the regions of vascular bundles only it producing the secondary xylem and secondary phloem. So these are the vascular bundles. So in this region only it producing the secondary xylem and secondary phloem. So these regions here it will not producing the secondary tissue. So here in this region only it producing the secondary tissue. So here these are the bicollateral vascular bundles. So this one is the first ring and this one is the second ring. So only this region only it is producing the secondary tissue. So second one is the cambium forms. Second one is the cambium. The cambium produces large proportion of vascular tissues only in the region of vascular bundle. So example for this is bignonia stem. So the young stem shows a wavy outline with prominent ridges and furrows. So at the start of secondary growth, the vascular and intervascular cambium becomes active and joined to form the cambial ring. So during the starting stage, during the secondary growth, so this cambium behaves normally, and this cambium ring behaves normally in the beginning and gives more secondary xylem towards inner side and less secondary phloem towards outside. However, after some time, so the cambium ring develops unidirectional areas of cambium at 4 diagonal points. Only at the first it behaves normally and it produces secondary xylem towards inside and secondary phloem towards outside. But after some time, so only at the 4 regions only it produces massive amount of secondary phloem, large amount of secondary phloem and less amount of secondary xylem, lesser amount of secondary xylem and more amount of secondary phloem. So these phloem masses intrude inwards, forming the 4 deep wedges of irregular width and supported by transverse bands of sclerotic cells. So here, so this one is, so here only at the first it behaves normally and producing secondary xylem towards inside and secondary phloem outside. So this one is the, here this one is a secondary phloem. Here it producing more amount of secondary phloem and here it producing less amount of secondary phloem. So due to which it shows ridges and furrows. So here only in this region only opposite is this phloem. It contains sclerenchymatous patches. Sclerenchymatous patches are seen at the phloem region. So only at the 4 regions only it producing more amount of secondary phloem and less amount of secondary xylem. So this is an example of bignonia stem. So next, the cambium forms irregular patches of parenchyma in xylem. So another case. So here the cambium which forms the irregular patches of parenchyma. So here example for this is Urtica dioica. So the young stem of Urtica, here it shows a typical dicotyledonous structure having a ring of conjoined open and collateral vascular bundles. So generally in this, it contains that is conjoined, collateral and open type of vascular bundle. So at an early stage, normal cambium ring is formed. So which behaves normally. That is cutting off the secondary xylem towards inner side and secondary phloem towards outer side. However, after some time, the cambium which begins to behave abnormally. So at certain places only cutting off parenchymatous cells. So generally this vascular bundles it produces secondary xylem and phloem, but here it producing the parenchymatous cells on inner side instead of secondary xylem. So in place of secondary xylem, it is producing the parenchymatous cells. So after cutting off group of parenchymatous cells, so the cambium again behaves normally and it resumes its normal activity, that is production of secondary xylem above the parenchymatous group. So the process is repeated again and again, so resulting in the formation of islands of parenchyma which are embedded in the secondary xylem or wood. So here in Urtica dioica, so here first the vascular cambium which behaves normally and it producing the secondary xylem towards inner side and secondary phloem towards outside. But after some time, so in place of secondary xylem, it is producing the parenchymatous cells. So after some time, again it resumes its function and it behaves normally, producing the secondary tissue. So this one, so here this one is the secondary xylem. So in between this secondary xylem, this one is a parenchymatous islands. So again secondary xylem. So next one is abnormal cambium showing the abnormal activity. So here a new cambium ring or accessory cambium which is arises from the cortex or pericycle. So here accessory cambium means the which is other than the vascular bundles region. So it is called as the accessory cambium. So which is develops from cortex region. So if the cambium which develops from the cambium, it is called as a cortical cambium, or from the extrastellar cambium, which is arising from the pericycle. So cambial ring being placed abnormally function in the abnormal manner. It is this cambial ring which developed from the so generally normal cambium which is present in the vascular bundles region, but here this cambium which is developed from cortex region or pericycle. So formation of rings of vascular bundles embedded in the parenchymatous tissue. So example for this is mirabilis stem. So the stem has a typical dicotyledonous structure. So extrastellar cambium, which is originates from the cells of the inner cortex, are from the pericycle region. So the cells which are present in the pericycle are inner cortex region. From this, here the extrastellar cambium is developed. So it forms a secondary xylem and secondary phloem. So a ring of conjoint collateral vascular bundle is formed and it is separated by the parenchymatous cells. The first cambium. Here, the first cambium ceases its function after forming the ring of vascular bundles. So here, the cambium which is formed from the other than the vascular bundles region, that is called as the extrastellar cambium is formed, and after forming the ring of vascular bundles. So here the cambium ceases, it stops its function. So the successive rings. So the successive rings are the successive rings of accessory cambium form the secondary parenchyma and which behaves in the manner similar to the first one. So the last cambial ring which cuts off sclerenchyma. So afterwards, so again new vascular cambium which is formed from the pericycular cortex region, and again it behaves less like that, and after some time, so it ceases its function, it stops its function, and again new one is formed. So the last cambial ring which cuts off sclerenchyma alternating with the secondary xylem on the inner side and secondary phloem and parenchyma on the outer side. So last cambial ring, it produces it produces sclerenchyma alternating with the secondary xylem, that is in place of secondary phloem, here it producing the sclerenchyma, and on inner side it producing the secondary phloem and parenchyma. So outer side it producing sclerenchyma and secondary xylem on the inner side, and secondary phloem and parenchyma on the outer side. It producing secondary xylem and sclerenchyma towards inner side, and secondary phloem and parenchyma on the outer side. So hence the last ring of vascular bundles are embedded in the lignified tissues. So here the anomalous activity is, so here the cambium which is the extrastellar in origin and which after the production of secondary xylem, so it ceases its function, again new extrastellar cambium is formed and it produces the same like that. So it produces secondary xylem and secondary phloem along with this. So sclerenchyma and secondary phloem on one side and inner side, and parenchyma and secondary phloem towards inner side. So here, so the sclerenchyma at the outermost ring of the vascular bundle. So here these are all produced from the cortex or pericycle region only. So this is the vascular bundle. So it producing, so here it producing the xylem and phloem. So here in last one, so it producing secondary xylem and conjunctive tissue, that is the cells which are sclerenchymatic or parenchymatous cells. Sclerenchymatic, so they are called as the conjunctive tissue. So here the secondary phloem and parenchyma towards outer side. So this one is the cambium, last cambial ring. 1, 2, 3. So next one is the formation of rings and vascular bundles embedded in the conjunctive tissue. So the cambial ring which originates in the conjunctive tissue and gives off secondary xylem tissue on the inner side and secondary phloem tissue outside. So the vascular bundles appear to be embedded in a mass of conjunctive tissue. Example for this is bougainvillea and Behaviour. So here the cambial ring which is originated in the conjunctive tissue. So conjunctive tissue is nothing but the parenchymatous cells which are present in between these vascular bundles, so it is called as a conjunctive tissue, and which gives off secondary xylem tissue on the inner side and secondary phloem tissue outside. So the vascular bundles appear to be embedded in a mass of conjunctive tissue. Example for this is bougainvillea and Behaviour. So in bougainvillea, so the first cambial ring is extrastellar in origin and arises from the pericycle, followed by the successive rings of cambia. So here the extrastellar cambium, which is originated from the pericycle. So the cells of the pericycle becomes meristematic and act as the cambia, vascular cambium or cambial ring. So the cambial ring, which cuts off secondary xylem, alternating with secondary parenchyma on inner side and secondary phloem and above the second xylem. So it produces secondary xylem and secondary parenchyma on the inner side and secondary phloem towards outside. So the cells of the secondary parenchyma are fusiform, more or less radially arranged and usually develop lignified thickened walls. So these are referred to as a conjunctive tissue or ground tissue. So the successive rings of cambia are formed, which behaves in a manner similar to the first ring. So it produces secondary xylem and parenchyma cells inside and secondary phloem towards outside. So successive rings of cambia, which behaves in a manner similar to the like that, it produces many successive rings. So in some species of bougainvillea, the conjunctive tissue consists of entirely sclerenchyma and cannot be demarcated from the xylem of the embedded vascular bundle. So hence the secondary phloem, which appear in the form of islands of isolated groups. So here this conjunctive tissue which is becomes sclerenchymatic. So hence it is called as a secondary phloem which is embedded in this conjunctive tissue. So this is the TS of bougainvillea stem. So it contains outer epidermis, so cork, cortex, endodermis, here pericycle, and here this one is the secondary phloem. So in between the secondary phloem, here the conjunctive tissue is present. So here, so this one are these are the vascular bundles. So it producing the secondary tissue. So these cells which are sclerenchymatic, so they are called as a conjunctive tissue. So in the conjunctive tissue, here the phloem is present. So this one is the xylem. So it produces. So this is the cambial ring. So it produces secondary xylem towards inner side and secondary phloem outside. So here so in bougainvillea stem, the cambial zone. So this one is the cambial zone, which is present beneath the starch sheath. So that is pericycle. Okay, starch sheath. So here it is present before the starch sheath, and the central part of the stem, which is occupied by the primary bundle. So central, they are the primary bundles. So within which the secondary growth is occurring. So from this only here the secondary growth is occurring. So internal vascular bundles are associated with the conjunctive tissue. So the primary bundle has been formed by the vascular cambium. So here this primary bundle which is formed by the vascular cambium. So these are the diagrammatic diagrams of this anomalous secondary growth. So next one is the Behaviour. So in Behaviour, so the vascular bundles are arranged in 3 rings. Okay, so here the vascular bundle, they are present in 3 rings. So inner ring, middle ring, and outer ring. So here the large centrally placed in medulla. So generally, as inner ring, it contains two large centrally placed. So 2 vascular bundles which are present in the central, and that is in the medulla region. That they are larger in size. Whereas the middle ring, which consists of 6 to 14 loosely arranged bundles. In the middle ring, it contains 6 to 14 vascular bundles. Whereas in the outer ring, it contains 15 to 20 vascular bundles. So the 3 rings of bundles which are originated from the procambial strands only. So the secondary growth in the 2 medullary bundles and in the bundles of the middle ring is limited. So here the secondary growth is limited in this inner ring and middle ring, resulting in the slight increase in the size. Only it is limited and it produces secondary growth and it is limited only. But The intravascular cambium of these bundles function normally and forming the secondary xylem on the inner side and secondary phloem on the outer side. So, as the secondary growth progresses, the primary phloem gets crushed due to production. So, they will come together, that is crushed and forming a cap-like structure of dead cells over the newly formed phloem. So, however, most of the secondary growth of the stem, which takes place from the cambial activity of the outer ring of the bundle. So, here the inner and middle vascular bundles activity is less limited, but outer ring which takes place in the secondary growth. So, the intravascular and intervascular cambium join to form a cambial ring. Cambial ring. So Maheshwari observed that the ring forms a secondary xylem in the intravascular region and lignified conjunctive tissues in the intervascular region. So generally cambium, which produces secondary toward the ring, it produces secondary xylem towards inside and secondary phloem outside. But ఇక్కడ ఏమవుతుంది, only in the intravascular, that is only in the vascular bundles region only, it producing the secondary xylem, and remaining region it producing the lignified conjunctive tissue. So the secondary xylem and parenchyma, which is opposite to the conjunctive tissue on the outer side. So after the formation of secondary tissue, the cambium ceases its function and new cambium ring arises from the joining of secondary parenchyma cells, that is opposite to the conjunctive tissue, that is outside tissues, and again it will continue. So this one is the TS of Behaviour stem. So this one is the, here these are the central two vascular bundles, larger central two vascular bundles. So these are the middle ring, which contains 3, 4, 5, 6, 7, 8 vascular bundles in the middle, and this one is the outer ring. So here it produces, it involved in the secondary growth. So here also, so this region, it is a vascular bundles region, it producing the secondary xylem, whereas in between these vascular bundles, it producing the conjunctive tissue. So this is about the anomalous secondary growth.
Okay, any doubt regarding of this class, my dear friends? Okay, madam, thank you very much. So you are clearly explained about the anomalous secondary growth, how it has occurred. The different trees depends upon the some of the monocots also shows about this anomalous secondary growth, and also some of the other plants shows about the anomalous secondary growth due to the cambium activation of the cambial rings, and other clear information madam has given. Really wonderful presentation, madam. Thank you very much. So tomorrow same time we will going to meet. Thank you.
Okay, thank you, sir.